All right. Hi, everyone. Let's continue our discussion on TypeScript. Let me quickly recap from the top what all we've discussed until now. Number one, we've discussed the various types of languages, specifically strongly typed versus loosely typed, Java, C, C++ being strongly typed languages, and Python and JavaScript being loosely typed. Because of the loosely typed nature of JavaScript, TypeScript was introduced as a new language to add types on top of JavaScript. What is TypeScript? It is just a language, or more specifically, it is a strict syntactical superset of JavaScript, and it adds optional static typing to the language. What this means is it is just all the original JavaScript syntax that you can write, plus some things on top that give you type safety. In the end, JavaScript is what reaches the browser and the Node.js. TypeScript is just a language in which you write code that eventually gets converted into JavaScript. The TSC compiler, or more specifically TypeScript compiler, is something written by the folks at Microsoft that lets you convert the TypeScript code into JavaScript code. So if I write some basic TypeScript code here, const x colon number equal to 1, if you run the TSC command, it will convert it into this JavaScript code, which, as you can see, does not have the TypeScript bits that you see here. This conversion is done by the TypeScript compiler. And there are a bunch of other famous popular compilers that I have mentioned somewhere here. If not in this slide, in a different one. The famous ones are ESBuild. There's one called SWC or SWR, I'm forgetting. And a bunch of others that let you do the same thing, convert TypeScript to JavaScript. Then we understood some basic types: numbers, strings, booleans, nulls, undefined, and did a bunch of practice problems. I would urge you to try these yourself if you haven't yet. Understood the tsconfig file and some standard configurations that you can change here to change your output from the TypeScript to JavaScript conversion. Lastly, we discussed interfaces and types, differences between them, why are they used, what are the things that interfaces let you do and types don't, what are the things that types let you do and interfaces don't, and usually what should you use? Wherever you can use interfaces, you should use interfaces. If there is a place where you cannot use interfaces, which is specifically things like unions and intersections, is where you should use types. This is all we've done until now. Now let's get into arrays in TypeScript. I think we've done this as well. So let me quickly recap this. It is just how would you represent arrays in TypeScript? And the answer is you add the array annotation right next to it. If you know there is a function called max value that needs to take an array as an input and return the maximum value in that array, the type of this array will be number followed by the array notation right here. Another good example here was if you want to filter all the users, where a user is of type user array. So if you have to filter all the users that are above the age of 18, find all the legal users who can vote in a country, then the argument to this function is user, which is this interface right here, followed by the array notation. So that's how you can do filtering, or that's how you can use array types in TypeScript. That's a brief of what we've done until now. Next, let's understand this thing called enums. Enums are not a JavaScript or a TypeScript specific concept. They exist in many languages. They stand for enumerations. Enums in TypeScript are a feature that allow you to define a set of named constants. This part is important. Let's try to understand what that means. The concept behind an enumeration is to create a human readable way to represent a set of constant values, which might otherwise be expressed either as a number or as a string. Too many things have been written in these two lines. Let's understand this better with an example. Let's say you're asked to write a game where you have to perform an action based on whether the user has pressed the up arrow key, down arrow key, left arrow key, or right arrow key. So the user will be expected to press one of these 4 arrow keys, and that arrow key will reach this function. The question I have for you is, what should be the type of key pressed? Should it be a string? Should it be a number? What should the type of key pressed be? Again, the logic does not matter. We are not worried about the logic. We're only worried about what should this argument be. Given we know it can either be up, down, left, or right. How would you represent these 4 values? Should it be a string? कि हाँ भाई key pressed can either be up or down or left or right. Should it be a number? कि हाँ 1 means up, 2 means down, 3 means left, 4 means right. Or should it be something else? Let's try to maybe code this quickly locally. There's not much to code. I can copy this and paste it here. As you can see, it gives me an error that says its value, it's implicitly has an any type. So I have to give it a type. The type I'm going to give it for now is, let's say, string. So now I can call it like this, up, or do something down, so on and so forth. What is the problem in this approach? The first problem is I can give it any random value and TypeScript won't complain. TypeScript won't be like, hey, array, I cannot accept down random g as an input. TypeScript feels like, okay, I expect a string. It has been given a string. And of course, your logic will fail. Your logic will eventually be something like, if key pressed equal to up, then do something, so on and so forth. There will be like 4 if checks here. And this does not lie in any of those if checks. Wouldn't it be nice if TypeScript upfront tells you, if TypeScript during your compilation step only tells you, that bhai, there is some bug in your code base, do something, cannot accept this as an input. How would you enforce that? There is one way to enforce that, which is without using enums. Ways you can define a new type here, call it whatever, key input, and you can say this will be either up or down or left or right. And you can say, okay, this is not a string. It is either of these 4 values. And now, as you can see, TypeScript begins to complain. TypeScript is telling me you cannot give this as an input. And we have found a bug in our application. If a developer wrote something bad here, we can, in the compilation step itself tell them, ki, haan bhai, something is wrong. So this is great. This is one way to get rid of the problem. This needs to have a more constrained set of inputs, up, down, left, and right, and not a string. But what are these? These are sort of constants, right? Up is up is a constant, down is a constant, left is a constant, right is a constant. And what were enumerations? Enumerations in TypeScript are a feature that allow you to define a set of named constants. This you will see across languages. The other line is also important. The concept behind an enum is to create a human readable way to represent a set of constant values. You might say, Harkirat, this is already human readable, up, down, left, right. Why do I need to add more human readability into this? Yes, you have a good point, but let's look at the syntax of enums and then see why enums might be slightly more human readable than what we see over here. You can make it string, you can make it numbers, you can also make it much more strict like we have over here. But what should you make it? You should make it an enum. The best thing to make it is an enum, and this is how you define an enum. Rather than writing type something equal to these 4 values, you can write enum direction, whatever name you want to give it, has 4 types, up, down, left, and right. Notice the syntax. It's very different from the syntax of type. There is no equal to here. It's simply enum, the name of the enum, and the values that this enumeration can take. Enum stands for enumeration, which means you can iterate over some constant values. In our case, we only have 4. We could have 2, we could have 1, we could have 100 values. You can define all of these here. And you can say, bhai, do something will not accept key input. It will accept direction. Isn't this much more readable? Ki haan bhai, key pressed is a direction, either up or down or left or right. And whenever you are calling it, you will call it with direction dot up or direction dot down, so on and so forth. And yahan pe also, here also, you will check direction dot up, direction dot down, so on and so forth. So we have just made things slightly cleaner to read compared to this. Does this syntax still work? It still works. You can always use enums and types interchangeably, but this is better for a few reasons. Number one, you can always over here type direction dot, and it'll give you nice suggestions ki this can be down, up, left, or right, versus when you're trying to write it like this, then there is no suggestion. I mean, you can still get suggestions, if I'm being honest, if you hover over it, and if this was key input, you could argue there is a way for you to read through the code and eventually reach here and then understand you have to write up. But it's much better for you to just write direction here, and then VS Code gives you a bunch of suggestions कि हाँ भाई, you can choose from one of these 4 values. That's one of many benefits of using an enum over a type like this. Cool. So what is an enum? Something you use when you know that there are limited set of inputs to this specific function, and these are like constant values. They can either be up, down, left, and right. Cannot be a randomly generated value like diagonal, top left, bottom right, or something like that. Cannot be west, east, or a random value. It can be only one of these 4 values. So you can define them in an enum. Cool. Now let's see what the JavaScript code of this looks like. This is the TypeScript code for it. Sorry about that. If this is the TypeScript code for it, let's look at what the JavaScript equivalent of this code would be if I run tsc-b. If I open the a.js file, notice something. Actually, let me do one more thing. Let me do a console.log direction.down. It's always very difficult to read these JavaScript files because, as you can see, there's too much code here. But let me do one thing. Let me log direction.down and direction.up also. Okay. And let me run tsc-b, and then let me run the final a.js file. What do you think will get logged on the screen? What do you think direction.down is, direction.up is? It's, as you can see, 1 and 0. Direction.down is 1 and direction.up was 0. Can you guess by this logic what this might be? It'll be this, and right would be this. So in the end, enums have no wajud. It's not like they will ever reach your JavaScript code. Even though you see where direction here, there is no concept of an enum here. And finally, when the if checks are happening, this direction.up is effectively just 0. So it'll be very hard for you to read this JavaScript code and understand that direction.up is 0. But if you looked at it, direction.down, what did it log? It logged 1. Direction.up, what did it log? It logged 0. Which comes to tell you, in the end, it's just creating a new direction object here where direction of up is 0, direction of down is 1, direction of left is 2, right is 3. These are the values that it assigns to these enums. So it's just a virtual concept in TypeScript. It never translates to anything here. It's not, enum does not exist as a keyword in JavaScript, or something that JavaScript even understands. Enum can only be used in a TypeScript file, and in the end, under the hood, it converts these values into 0, 1, 2, 3, or like if you have another value here, then 4, so on and so forth. It's just much easier to read when you're writing TypeScript code, because you can pass values like this. This can do if checks like these, so on and so forth. You can always look up direction dot left. Acha, makes sense. This is what the one of 4 variants of direction is. All right, cool. That's what an enum is. This makes code slightly cleaner to read out. The final values stored at runtime are still a number 0, 1, 2, and 3. We tried logging direction.up, and what did we see it got logged? 0 got logged. Again, if you log down, 1 will get logged, so on and so forth. Question you might have in your head is, what if I want to change these values? If I don't want them to be 0, 1, 2, and 3, I want them to be, a string at runtime. If someone logs direction.down, I want down to get printed here, up to get printed here, so on and so forth. I still want the TypeScript developer, the person who's writing the TypeScript code, to use these annotations for them to write this clean code. But I want कि हाँ runtime पे this actually becomes down. This becomes up. So you can write basically code like this when you're defining your enum. कि हाँ भाई, up represents up, up, the string. And as soon as you do this, as you can see, it tells you कि भाई, if you've changed the first one, then you have to give all of them some string value. You cannot just give one thing a string value and then TypeScript cannot infer what this might be based on that. So either you give no one a value, then TypeScript will be like, this will be 0, this will be 1, this will be 2, this will be 3. Or if you have given one of them a type, you should give all of them a type. Now, if I rerun this code, you will see down and up gets logged, because now at runtime also, if I open a.js, direction of up is being set as up, down is being set as down, so on and so forth. So what did we learn? This is how you can define an enum. And if you want to give it a value, you can explicitly give it a value. One more thing I'd like to point out here, okay, you can also do this. If you want, ke bhai, I still want them to be numbers, but I want it to start from 1, and this be 2, and this be 3, so on and so forth. So you can be like up is 1, and it will automatically make this 2, 3, and 4. So there's one special case here, okay, if you want them to go from 10 and then 11 and then 12 and then 13, you can give the first one a value and rest of them will get values automatically. Or you can give, all of them values if you want. Yeah, 10, 100, so on and so forth. Not even sure what the value will be in this case. We can always log and see. But if I make this 1, and then if I rerun tsc-b, I see this becomes 2, this becomes 1. That's what gets logged here. If I make the first one 10, then they'll probably become 11 and 10. Let's see. Yeah, 11 and 10. If I make the first one 10, and second one 20, then I don't know what will happen. It'll probably be 10, 20, 30, 40. Yeah, 10 and 20 look right. Let's also log left. Now it's 10, 20, and 21. So 10, 20, and then here onwards, they're all going incrementally. You will never do this, by the way. You'll never partially give it values and not give it values later on. You will either let them be 0, 1, 2, 3, like this, or you will make them strings. Usually you will see one of these two things happening. When you're making it a string, you have to give all of them a value, up, down, left, and right. All right. In the end, this value does not matter, because throughout your code base, you are using direction.down, direction.left, type is direction. You are never using UP. You of course can do this, but then that takes away the purpose of introducing the enum. The purpose of introducing the enum is now everywhere you use this, you write this clean syntax, key plus equal to direction.left, call it with direction.right, log direction.down, so on and so forth. You don't ever use constant literals. You don't ever use this equal to left. You use this. Okay? All right. That's what enums are. Let's see if I'm missing something here. Yeah, a common use case in Express. So this is one code I wanted to take you through really quickly. We have written Express many times now. Const app equal to Express. And in Express, let's see something with this code. There you go. In Express, we return various status codes, right? If there is some issue here, we return some 411 status code. Then if everything is right, we might return some, 200 status code, so on and so forth. If it is 200, we don't have to give it a value itself. You can simply do rest.json. By default, the status code is 200. There are some standard status codes you will send back, 200, 404, 411, 500, so on and so forth. So here also you can create an enum. Response status is an enum. Success pay, it returns 200, not found 400, and error 500. And rather than putting 411 everywhere or 404 everywhere, you can simply put this status.not found. What benefits does this give you? Benefit number 1, much easier to read this than 411. No one knows what 411 represents, but a developer can read response status.not found, enum.not found. This probably represents the not found status code. That's benefit number 1, easier readability of a constant. Benefit number 2 is, if let's say you have 2 routes and both of them use not found, and then suddenly the not found status code changed from 404 to 411. Then you can make that change in just one place. You can be like, not found is 411, and then all of these will start to return 411 versus If these were constant literals, then you would have had to look through your code base. Okay, where all am I using 404 and make that code change everywhere, versus now you can make that code change in a single line. Cool. That's what enums are. A popular use case you might want to build, or you will see, is this key. The standard status codes that your application returns are usually created as enums, similar to this one that you see right here. That's all I had for enums. Would urge you to try all of these one by one. All right, next up comes the most interesting and hard concept of TypeScript, called generics. Generics are a language independent concept. They exist in C++ as well. You'll see them across many languages. Let's learn them via an example. All right, slightly hard concept. Bear with me for some time. Problem statement. Let's say you have a function that needs to return the first element of an array. Array can be either of type string or an integer. How would you solve this problem? I repeat, what is the problem? Okay, given a function max first L, which takes an array as an input, which is of type array of either number or string, and it needs to return array of 0. All right, this is the function that you had to write. You can write it in a different way. You can create a type input equal to number or string and make this an input array. This is slightly cleaner way to write it. Given this, let's see what the problem statement says next. What is the problem in this approach? Can you guess already? Given this code base, given this TypeScript code base, what is the problem in this? Let me share a few. Const value equal to first element of 1, Harkirat, sing. I give it 2 values. It should return me the first value, which is Harkirat. What will happen if I log value here? As you might have been able to guess, Harkirat gets logged. What is the problem in this approach? Let me share that. Let's say I want to print the final thing in uppercase. So I want to call value dot to uppercase, which is a function that exists in JavaScript. If I go to my console here and I type Harkirat dot to uppercase, it gives me Harkirat in the uppercase. So you can always call to uppercase on a string. And here, if you look at it, I have given it 2 strings as an input. So what should the type of this thing be? If TypeScript was really smart, it would have known that string came as an input. 2 strings came as an input. So what this will return will probably be a string. And hence the value of this would have been a string. And TypeScript wouldn't have complained here. What is the complaint that's happening here? It is property to uppercase does not exist on type input. More specifically, property to uppercase does not exist on type number. You cannot do 1.to uppercase. You can do Harkirat.to uppercase. You cannot do this. And TypeScript, even though it should have been smart enough to know that bhai, this returns a string, but if you hover over it, you can clearly see TypeScript says, bro, I got input array. I feel like this will return input. Could be a string, could be a number. It's not necessary that this returns a string. You might argue कि नहीं Harkirat, देखो, I have clearly said कि both the things are strings. How does TypeScript not figure out कि हाँ भाई, given 2 strings, the value that it should return should be a string? The answer here is because TypeScript cannot run any code. As I've said this many times, TypeScript is just looking at what are the types of everything, and it understands that by given array input array, return array of 0 means this guy returns input, which could either be a number or a string. And hence, if you try to call dot to uppercase on this, TypeScript doesn't let you run this code or compile this code. TypeScript gives you an error. If you try to compile this code, it clearly says there is an error. You cannot call to uppercase value can either be a number or a string, which, well, you cannot con upper to uppercase on a number. That is a problem. How can you fix this problem? You can't really think about it if you don't know about generics. If I'm being honest, you just have to study here with me. But I hope you understand the problem. Okay, ideally, this should not return you an error. If you wrote just JavaScript code, there wouldn't have been any error because, well, there is no type checking there. But here there is type checking. And even though you would think TypeScript would be smart enough to figure out, given this input, it should return a string, and TypeScript would be smart enough to figure out this is a string. It is not. TypeScript is like, given input array, output is going to be input. And since input can either be a number or a string, I will prevent you from calling to uppercase. I am TypeScript, I am strict person. Strictness check is failing here. Number pay, you cannot call to uppercase. How can you fix this problem? This is one of the problems. Let's see if there's another problem. I saw two things here. User can send different types of inputs as in, this is another problem. Ideally, you want whoever is calling this either gives you only strings in this array or gives you only numbers in this array. You don't want to allow someone they can give you a mixed bag. Numbers are also here and string is also here. But as you can see, TypeScript is not complaining because what have you written? Arrays of type input array, which is either a string or a number array. So can be numbers, can be string. You can send in a mixed bag here, which is something you don't want. You want either it is a number array or it is a string array. You might argue, Harkirat, then I can do this. String array or number array. Yeah, you can probably do that. That is one way to fix this problem. But let's say, that is one way to fix this problem. You can totally fix the problem like this. Now, as you can see, TypeScript begins to complain. You can either give it 3 numbers or you can give it, a few strings. You cannot give it a mixed bag of strings and numbers. TypeScript will complain because I've said either a string array or a number array. Value that it returns is still string or number. So the first problem still persists. Second problem we were still able to fix by doing this. But is there a better way to solve this problem? What are the problems again? Let me quickly recap. First problem was, if you use it like this, you can send in a mixed bag. And ideally this should only, the problem statement is first element will expect, or you want to send in only a single type of inputs, either all numbers or all strings. You don't want to give in a mixed bag. And secondly, the value that it returns, it's not able to infer it correctly. If I'm giving it 3 numbers, it should be able to infer, this is a number only, this will return a number only. This will never return a string. And if it will return a number, basically this type should be inferred correctly. If it's not inferred correctly, it can give you problems later on. For example, we saw, if you are passing in a string, it infers the return type as input, and hence you weren't able to call value dot to uppercase. As you can see, even VS Code doesn't give me suggestions because VS Code is like, bro, you cannot call to uppercase. This is either a number or a string. This is not just string. How can you fix this problem? The solution for this is generics. Generics enable you to create components that work with any data type while still providing compile time safety. That's a pretty textbook definition. Let's understand this through an example. More specifically, this is a small example. You can look at this. This is like the smallest example of a generic, which is, if you know, there is a function called identity, which let's say can take a string as an input or a number as an input. So rather than doing, what we did in this code right here, you can do something like this. The problem statement is, let's say you have to take something as an input, which could either be a string or a number, and then return that as such. That's what this identity function over here is. Let's try to copy it and bring it in our code base. Let's try to explore this. It says identity will take, let's look at how we have called it first. Let me remove this. I am calling this, let's forget all TypeScript bits for now. I am calling identity either with a string or with a number. And I have to give this a type. I can either be like this thing that we did until now, string or number. We can do this, almost works. What is the problem? does not know, okay, bhai, if I've given a string, return value is a string, still feels like this can be both string and number, even though it should be able to figure out, okay, this is just a number. How do you fix it? You say, okay, by identity can be called with anything. That's what this T represents. You have to add this syntax for a generic. Okay, bhai, this can be called with a generic value, with any value. And that's what the argument will be. The input argument is generic. Can be a string, can be a number, can be something else. Identity will take something as an input, which could be anything, could be string, could be number. I don't know. The person who has defined the function does not know. He said, whoever is calling the function can tell कि हाँ identity is being called as a string or identity is being called with a number. That is what a generic is. कि भाई during definition, I don't know the type of this. It can be anything. It is a generic function. Anyone can call it. And when they are calling it, they should just define कि भाई I am calling this with t set to string. And this guy can say कि I am calling this with t set to number. That way, you can think of it as you have created two variations of the functions. An identity one function that is taking number as an input, and an identity two function that is taking string as an input. And the first one will call identity one, and the second one will call, identity one and identity two. Yeah, that looks right. So you can think of generics as being able to create multiple variations of your functions, one for number, one for string, and I can keep going here. I can give it a more complicated type if need be. Let me revert the code back to what it was. There we go. That's what the code looks like. And how has it changed? Rather than it being this argument can be either a string or a number, it says argument can be anything. And this is what that anything can be. Whoever is calling me, tell me the type. Give me a generic value. Could be a string, could be a number. And that is what the first argument is. The first argument is this generic value. And when it's being called, the person who's calling it with a string gives string as the template here, number the template. Why is this beneficial? Number one, what is the return type? String. It was able to figure out that this isn't string or number anymore. Since it's being called with the generic, which is a string, it will return arg, which is the thing that went in, and hence it is returning t. I can also explicitly say that this returns t only, but TypeScript can infer that as well. Okay, bhai, argument was t, returned argument, which means it will return t. It will not return string or number. It will return string here. It will return number here. That's how we got rid of the original problem. Ki haan bhai, I can now very clearly do dot to uppercase. And no type errors come because output 1 is of TypeScript. I can hover over this and it is of type string. And output 2 is of type number. Try to pause here and marinate this code. Let's try to solve the original problem as well. The original problem, if you remember, was this right here. I would urge you to code it yourself if I'm being honest. Get first element will now not take string or number as an input. It will take by generic value, can be called with a string, can be called with a number, can be called with whatever. And whoever is calling it, the array of that template is the input and the return value is arrow 0. If you want to make it more explicit, you can, this kit still returns t, but again, this can be inferred. You don't need this part. When you're calling it, you can explicitly say, okay, bhai, this is a t for when I'm calling it a string. And if you want to do another call with numbers, then you can put number here. Even if you don't do this, TypeScript can automatically infer कि हाँ भाई, I knew it was a t array. Person gave a string array, which means t is string for this one. So you don't have to explicitly provide string over here. TypeScript figures that out as well. Even if you do, either way, the benefit here is, as you can see, 2 lowercase is no longer erroring out. And why is that happening? Because L is of type string. It is no longer of type number. In fact, if you look at this code base, you don't see number anywhere right now. So if you don't see number anywhere, how can number be inferred as a type here? But Kirat, does that mean we don't have number functionality anymore? No, you can still do this. And now what will the type of L2 be? It will be number. So I can also, keep calling this. I can call this for a boolean. And now what is the type of this? Boolean. The type of this? Number. Type of this? String. Cool. So that's how you can, and still the other problem also goes away. I cannot give it a mixed bag. If I try to give it a mixed bag, well, I can give it a mixed bag because it'll just feel like, yeah, this is a string or number template. It'll just assume that this template is string or number. So if you want to prevent the problem of a mixed bag, you should explicitly tell that bhai, here the template is a string, so that the person cannot give you something other than a string. If you don't give it this, it will not give you an error because it will assume that the type is string or null. This can be a very complex type. You can also give it like the user type here. If you define an interface user name string, you also give it a user type here. This is an array of users. So this does not necessarily need to be a primitive value like a string or a number. It can be a complex value. What is the benefit? L ka type is user. So you can do whatever you want. L dot name. Because the first element or this returns a T, and T in this case is user, in this case is number, in this case is a boolean. All right, that is what generics are, and you will see these quite often in open source code bases, bigger code bases. So always good to clear this out, what this syntax means, because this boggles heads a lot whenever people see this for the first time. All right, that's it for generics. Let's move on next to exporting and importing modules. All right, one last thing to discuss before we end it is another way to import and export modules. Until now, we've been doing this const express equal to require express. Even though this is good / one way to import modules, there are better ways. More specifically, TypeScript follows the ES6, which is like a more modern system using imports and export statements to share your code between files rather than doing this. Can you still do this? Yes, but is it better for you to import like this? Yes, this is slightly better. You see type errors right now because I haven't installed npm express, and also when you're installing express and you want to use TypeScript, you have to install @type/express as well. We'll discuss this in more detail as time goes by. But you can do either one of these syntaxes. Which one's better? This one's better, slightly more cleaner. This is the new syntax to import modules. And what is the syntax to export modules in case you want to export them? It is this: export const a equal to 1, let's say. We've done this in React, so this might not be very new to you, but generally, even in backend applications now, if we are using TypeScript, which is what we will use from now on, follow the ES6 module system and use import and export statements to share code between files, rather than using the module dot exports equal to a:1. This syntax, this is the better syntax. One more thing to know here might be default exports, which is if you export like this: export const a equal to 1, export const b equal to, let's say, 2. And then the way to import it in another file, for example, a.ts, is this: import a comma b from /b.ts of this file. But if you export default a equal to 1, let's say, you export default const a equal to 1, export default a. Sorry, this is the syntax. If you export like this, then the way to import it in the other file is this: import a from ./p. Basically, you don't have to destructure the object. You can import it by default and you can name it whatever you want. Harkirath, if you want, console.log. Harkirath would give you what? What is this file exporting by default? It is exporting a, which is 1. So even though I import it as Harkirath over here, it will still print 1 here. Yes, still prints 1. If I exported const b equal to 2 here, I can still import, Harkirath by default and b as a constant. If I rerun this, you will see 1 and 2 gets logged because b is imported as a constant. Harkirath, or if you want to call it a is imported as default. This might bring back some memories from React. You can do import use effect from React, or you can do import React from React as well. Sometimes you want to use this. For example, if you might remember, we used react.memo. So you can do this, or you can do this, so on and so forth. Just another syntax to do imports and exports in TypeScript. More details are present here. Specifically, the thing to know is how to export constants and how to do default exports in TypeScript. That's it for this one. And I think that covers pretty much all the TypeScript we need. I think the only thing that's left to do is a lot of practice. So I'll try my best to put out a video this week, if not this week, then next week, on a full end-to-end project, but that uses TypeScript for the backend. Everything else is the same. Only thing, the language is going to be TypeScript. And for front-end React, we are going to use TypeScript as well. All right, I'll see you guys in that video. With that, I think that ends TypeScript. I'll see you guys next week in the next offline video. Bye-bye.